Alright, Chem students, this is a quick review for electrons and periodic table test. Hopefully you've already completed your practice test, checked it against the key. A lot of these with the definitions and stuff like that I'm not going to cover, but there are some questions that we definitely want to make sure that you knew the answers for, and these are some of the most commonly asked questions too. Now, first thing, wavelength and frequency are inversely proportional. That means if one goes up, the other one has to go down. So it would look like that. Now, energy and frequency are directly proportional, meaning if one goes up, they both go up. So again, wavelength and frequency inverse, meaning one goes up, one goes down. Energy and frequency are directly proportional. One goes up, they both go up. Now, you can list the parts of electromagnetic spectrum, that's in your notes, but I do want to cover how to interpret that table. So your table will look like this. When the waves over here are squished together, that means they're high frequency. When they're longer and farther apart, that means low frequency. It also means a longer wavelength. So when they ask which type of electromagnetic radiation has the highest frequency, you would pick gamma, because it's all the way to the left. It's the highest frequency there is. Now, because frequency and energy are related, highest frequency would also mean highest energy. So it's gamma again. The longest wavelength, as you can see down here, is definitely radio. Now, for calculating frequencies and wavelengths, you're going to be given the C equals frequency times wavelength and the associated number for speed of light. You just have to know how to use it. Now, every time you do this, it will always come out to be C divided by whatever they gave you. In this case, it was wavelength. So we put 3.00 times 10 to the 8th, divide it by 6.90 times 10 to the minus 7th. That will equal 4.35 times 10 to the 14th hertz. Alright, now for energy, you're going to use Planck's constant and a frequency. So if we ask for energy, you're going to set it up like this. H times F. H is right here with our constant, and then the frequency that they gave us. So our answer will be 4.63 times 10 to the minus 18th joules. Okay, another one we get a lot of questions on is for the different sublevels, how many orbitals they have, how many electrons, and their location. Now, the number of orbitals, you remember orbitals are the shapes of the areas where the electrons go, and each orbital can hold 2. So in our number of electrons, you can always fall back on this, count on your periodic table. S has 2 in its row, P has 6, D has 10 in one row, and F has 14. Now, if each orbital can only hold 2, that means S only has 1 orbital, P has 3, D has 5, and F has 7. This is also the number of lines you would have if you were filling in orbital diagrams with the arrows, if that helps. Now, the location on the periodic table, technically it's group 1 and 2 plus helium for S, or you can think to yourself it's on the left side. P is 13 through 18 on the right side of your table. Groups 3 through 12 are your D block. That's right in the middle, and then the lanthanide and actinide series are at the bottom. Now, these are your 3 rules as it relates to electron configuration. Pauli exclusion principle says that each orbital can only hold 2 electrons at most, and they have to have opposite spins. So your arrows need to be going in opposite directions, one up and one down. Hund's rule says that for each sublevel, each orbital gets 1 electron before any get 2. So if I have 3 p orbitals, I have to put 1 arrow up in each one before I can go back and put an arrow going down. And then lastly, Aufbau principle says that electrons always enter orbitals of the lowest energy first, meaning we will always start at 1s2, 2s2, etc. You always begin at 1s2. Now, for this page, most of this you can check directly with the key for the review, but you are going to quickly see that this one right here is the one that is correct. And then you can explain why these other ones are incorrect based on with the key. Again, these all can be checked with the key. I'm not going to go spend a lot of time doing it because I don't have a periodic table to walk you through it, but check the key for these. Alright, so for 20 and 21, we need to know the number of valence electrons for each of the following. For number 21, if you had written the electron configuration, you could add up all the electrons in the outermost energy level, or if you don't have that available, you can go to your periodic table, look at the top of the group that element is in, and see the number in front of the capital letter A. That's also the number of valence electrons for that entire group. So for here, these would look like this. And then for number 20, strontium, we can look and see has 2. We would draw them like this. You want to put them as far apart as you can. Alright, carbon would look like this. Selenium would look like this. Boron would look like this. Iodine looks like this. Okay, now for number 22, define a group on the periodic table. What can we say about the number of valence electrons for the elements in the same group or family on the periodic table? That's basically what I just said. So group equals a vertical column going up and down. They will have the same number of valence electrons. An example of this is name an element that has chemical reactivity or properties similar to calcium. Magnesium would fit that, and it basically could be any element from group 2. They will all have properties similar to calcium. Alright, another one we get a lot of questions about is 24. First, you want to decide, is it to the left or right of that zigzag line? So magnesium is to the left. It is a metal. Chlorine is to the right, so it's a non-metal. Lithium is to the left of the zigzag line, so it's a metal. Now the E-dot structures, just like we did a second ago, magnesium has 2 dots, chlorine has 7, lithium has 1. Now, magnesium is going to lose these 2 electrons and become magnesium 2+, and then chlorine is going to gain 1 and become chlorine 1-. Lithium will lose the 1 and become lithium+. Now, down here, the electron configurations for the atoms on magnesium, chlorine, and lithium, these are how they are right now. So we are going to convert these based on whether or not they're gaining or losing. So magnesium, we already said, is going to lose 2. It'll lose those outer 2 and become 1s2, 2s2, 2p6. Chlorine, we said, is going to gain 1, so that 3p5 will become 3p6. And lithium is going to lose 1, so it will become just 1s2. Okay? Now, to show how the electrons transfer between each other, we're going to use calcium and chlorine as an example. Calcium looks like this when we draw it, and chlorine would look like this. So this 1 electron on this side would go to the empty spot where chlorine needs 1. Now we still have an electron that needs to be put somewhere, so I'm going to draw another chlorine over here, and then I'm finished. Now, periodic table stuff, you can look and find this in your notes or on the key, so I'm not going to cover it right now. The same thing with this. This is all definitions and talking about properties and stuff. You can look at it on the key. But I do want to cover a few of what we did most recently. The best way to do this is to make sure you can make these adjustments on your periodic table. Right up in the left corner, AR and IR, meaning atomic radius and ionic radius, show that they increase going down and decrease going across. And then on the other side, ionization energy and electronegativity. That one increases going across and decreases going down. Okay, so we can use that to determine the answers that we want to have. Alright, so if we're looking at our chart and we find arsenic and bromine, we would pick arsenic as the one that's larger. Now, for nitrogen and arsenic, nitrogen is above arsenic, so arsenic would again be larger. And then between lithium and neon, lithium would be larger. Now for number 36, which element has the greater ionization energy? That increases going across and decreases going down. So if we find potassium and krypton, it is definitely going to be krypton. Now lithium or potassium, it decreases going down, so lithium will have the greater. And then between sulfur and selenium, sulfur is right above selenium, so sulfur is the one that has the higher ionization energy. Now, electronegativity, that's using the same concept. Between phosphorus and chlorine, chlorine has more. And then fluorine and chlorine, fluorine is above it, so fluorine has more electronegativity. And then magnesium or barium. Barium is way down near the bottom in the same column, so magnesium has more. Now, the most electronegative element on the periodic table, because we can't count noble gases, is fluorine. Now lastly, you definitely need to look over your chart that you colored that looks like this. Make sure that you know that the alkali metals are right there. The alkaline earth metals are the one right next to it. Our transition metals are the ones here in the middle. Our other metals are this little section here. They don't really have a special name, we just call them other metals. And the metalloids are the green ones along the zigzag line. Now the other non-metals are right above the metalloids. Then we have the halogens, the noble gases, and then down here at the bottom we have the lanthanides and the actinides. Okay, I hope that helped. Study hard. Let's hope everybody does well on the test.